I'd like to begin my presentation. I am Hiroaki Ozono, the Test Automation Team Manager of LINE Fukuoka Development Division 2. The title is Pull Request-Driven E2E Test using Kubernetes, and this session is for people who are interested in E2E test automation or technology like Kubernetes. And this is today's agenda. I'd like to briefly talk about the session outline of this session, especially some point of discussions I'd like you to focus on, and I'd like to introduce team briefly, and then taking an example of a real project, how we have dealt with E2E test and what sort of issues we faced. And then after that, using Kubernetes, how we solve the problem. And then at last, I will give you a summary to end the session. I'd like to briefly talk about the session overview first. And I would like to talk about the E2E testing in this session. And have you provided test automation services regarding UI? Because the automated testing related to UI is the topic of my discussion. And I feel the number of E2E test cases has increased in recent years, not only in the web industry. E2E automated testing has become a commonplace, and there are more and more things such as OSS tools and integrated platform. What I am going to talk about today is a search for a new way to operate this E2E test. And I am comparing what I am going to discuss today. Briefly, the E2E tests have traditionally been conducted from an independent environment for already completed applications. And as the illustration on the left shows, there is a production environment where the users work on, and also the testing and staging environment. And to the completely deployed environment, or E2E test has been conducted as an independent environment as black box. And what I am going to talk about today is to shrink it to the pull request level, as the right hand side figure shows. And in order to do this, from the service deployed to delete, all the life cycle needs to be managed, and therefore we use Kubernetes. And there are two major things that I'd like to cover today. First, in order to solve these problems, I'd like to talk about a new role called SET, and the automated testing engineer that the team has dealt with in the past, and how is this different, and why did we need such a role in the team. I will also talk about technical aspects. In order to create the ideal E2E test environment, what sort of technical challenges have we faced and have we solved? I'd like to introduce my team at LINE Fukuoka. In the development center, there is a test automation team specialized in testing, made up of 6 engineers, and our main business is to write and operate E2E tests for various projects such as web applications and mobile applications. For the technical stack we are using, as the right-hand side figure shows, for web applications, Serenu and iOS and Android, and for mobile applications, the OSS called Appium is used. And also in order to flexibly and effectively operate E2E test, we may prepare libraries on our own, and especially for execution and recording, we think these are very important, and we think we have to build it from scratch so that it will be in line with our existing system. That was the introduction of our team. And then with the traditional E2E test, what is the scope of project? And also, what sort of effects have we seen? And also, in order to do E2E testing, what sort of issues have we faced? And I would like to share some examples of projects. And the project that I am going to talk about is the LINE Creator Market, which is our service, and you may have used this. The LINE Creators Market, the user creates the LINE stamp and can sell through this service. And as a web application service, this is deployed. And the LINE Creators Market, one of our team members, as an automated test engineer, is participating. And next, since our team members participated in project, what have we done? My team member joined the LINE Creators Market, and it's been about 2 years since the team joined, and the QA and testing are done in the staging, and also the production environment where the user actually interact the automated test domains. And after they join the project, they have created about 100 test cases and have regularly implemented once a day. And in this project, we are focusing on regression testing because this is such an important factor. And so we are focusing on important user scenarios to do the automated testing. So compared to the traditional testing, volume may be big, but few number of cases instead. And what was the effect of E2E test? By doing the regression test, we could see the improvement of quality, and especially for the cycle that we release a few times a month, to manually test the entire application features is not realistic, as you may have experienced as well. And there are some issues that we could have missed because of the lack of resources or because of huge costs and could not test it. But some bugs are found in the past. By automating this, it can be regularly checked, which is a big benefit. And also, there are things that can be done because it is automated. For instance, on Excel base, by checking, there are some small changes that human beings may overlook. For instance, the image, the difference of the image change using image matching, we checked in the test case, and we could detect very small pixel by pixel differences. LINE Creators Market, the creators are creating the details, and therefore, in the traditional application, maybe there is some small rendering change which might create a huge problem. So we could gain some effects or benefits because of the implementation and the operation of E2E test.
However, as we run automated testing, we've also found some issues. Some problems which are specific to E2E tests. Data dependency, which makes data rather unstable. And also low parallelism, as well as long execution time along with that, have become obvious. So let me talk about these. In terms of parallelism, as I mentioned earlier, in the staging and production developments. We have a single database used for multiple testing, multiple developers, not multiple testers. That could result in unintended changes, hampering tests. That is something we see often in E2E testing. Therefore, in relation to this, multiple tests, parallelism has become difficult in some of our E2E testing. Now, before test case is executed, using APIs, test data sets can be created for the test. However, for global things, it is difficult to set them beforehand. Therefore, there is a limitation in parallelism. Sometimes you are forced to do the test in sequential manner. You complete your test 1 and then move to test 2, and so forth, meaning that we have longer execution time. Another major challenge was a late feedback to developers. So imagine, for example, in the staging environment, you find a bug, but it is too late to feed that back to the developers. If a pull request is made and merged immediately, and QA testers find bugs in the staging environment immediately, that wouldn't be a problem. But if it takes some time before merge, or multiple pull requests are making changes to the same file or the same functions, the story is different. Therefore, it could take longer for complicated changes, resulting in the late feedback. The developers forget what code they wrote as soon as they write it. So, the feedback in the staging environment could be too late for the developers. So, I decided to take this simple approach of using E2E testing for all the pull request codes. For pull request, unit testing and integration testings are done automatically, so I decided to apply the same approach. In unit test or integration test, may not be E2E. In my case, it is E2E, meaning that you have to deploy the entire service. So, what I'm going to talk about is how I implemented that using Kubernetes. So before I get into more technical details, there is another thing that I would like to discuss. As I said earlier, there are two major topics that I would like to cover today. So here is the one that is about the role. SET is a title you may not be familiar with. And there is another term which is related to SET, DX. So I will discuss what they are briefly and describe how SETs are different from automated test engineers. So here is the definition of SET, standing for Software Engineer in Test. One of the roles of test engineers, and this has been quoted from Testing Google blog. As you can see, the software engineers or SETs build the frameworks and packages required to implement automation. Writing E2E test cases is a part of their jobs, therefore. Now, DX is another term which is deeply related to what I'm going to talk about. DX stands for Developer Experience. Building environment friendly for the service developers, leading to quicker deliveries of application as well as higher quality of applications. So DX has become a very important term for us in our team because we are a team of engineers helping engineers. So, how are SCTs and automated test engineers different? First of all, in terms of the test automation engineers, they aim at higher application quality. For example, automating conventionally manual tests. You can control something which used to be difficult to execute, or you can find something you missed in the past. But that may not lead directly to enhanced developer experience because of the late feedback, as I mentioned earlier. On the other hand, SCTs focus on the easier way of working for the service developers, improvement of their environment. For example, various tests run as a norm without service developers being conscious of them, and they're done very fast, and quick feedbacks are given. However, SCTs may not directly contribute to improvement of the application quality. Their contribution tends to be indirect. So, both SCTs and test automation engineers work in tests as engineers, but they aim at different things. I'm not saying that the automation test engineers do not contribute to enhanced DX, and also SCTs can also contribute to quality of applications. Both are important roles. Both are important responsibilities. What I'm saying is that they have different main targets. Currently, in my team, both of those roles exist, and they work in different projects as those projects may have different requirements. Now, let me move on to the next section of my talk. I will discuss how we run E2E test on pull requests, what sort of architecture, configuration, and technology stacks are being used. First of all, this mechanism itself coincides with the life cycle with pull request itself. I'm sure this is familiar to you. You may change some services. You may develop some features of services. You rewrite the code, push it to GitHub, request your colleagues to do a code review, and during that time, various tests run with CI, and it'll be merged to some branch or another. Review and test can take place at the same time or in reverse order, but this is how peer-driven tests are run, pull request-driven tests are run. In other words, when the pull request is generated, services Docker image is built and registered to a Docker registry. While your colleagues review it, it will be deployed to Kubernetes clusters. Unit tests and integration tests run in CI, and E2E tests run at the same time. When the pull request is merged, this environment is deleted.
Here is a diagram that details this in a little more detail. All the handling is done by GitHub app, the deploy, testing, start and at the end. It's all controlled so that it can seamlessly handle the next action. And in line with the lifecycle I talked about, for instance, when the GitHub app detects that a pull request has been made, it will build and register some Docker image on CI service. After that's done on the Kubernetes cluster, pull request by pull request services are deployed. And by pull request, the data independence needs to be ensured. In other words, database and also related E2E test necessary data are deployed in Kubernetes as pod. After the service is deployed and after confirming that the service deployment is successful in various checks, such as health checks, the GitHub app will run the automated test. At this time, the automated test and browser instance is generated separately from the Kubernetes cluster. The pull request close is a hook trigger to remove associated Kubernetes pods, which is the end of this life cycle. Here are two major things that I'd like to cover in relation to Kubernetes. First, how to manage Kubernetes manifest, and the other is about routing. I'd like to cover further details about the manifest of Kubernetes to begin with. How Kubernetes manifest is managed, which is a big discussion point, which is very important. And Kubernetes manifest is simply how to move Docker image and the file to describe that. Within Kubernetes, the name of metadata or the size of CPU, such as unit, and also environmental variable can be defined in the manifest. You don't have to worry about creating a manifest with the same fixed value every time, but in this case, you need to dynamically register the pull request number, git commit hash, etc. in the manifest to determine which pull request it is. There are various ways to manage this. There are various solutions, for instance, Customize and Helm, as well as Ksonet, whose development is over. In conclusion, in this case, variables to dynamically embed are also limited, and also there are many changes. There is no possibility of changing templates radically, so there are many options and no need to make major changes to template. Therefore, in conclusion, we chose Customize. Customize has been included in client tools officially provided Kubernetes since Kubernetes version 1.14. Customized files are shown on the left, and left is customized file. And within the customized file, there is a parse section. Define the variable that you want to inject in the parse section and embed in the config map of Kubernetes and can put it in the Kubernetes manifest. This customize will pass pull request number and commit hash from the environment variable and will be able to tell which service was deployed, and we pass the variables to Kubernetes manifest, and so we handle it as the deploy information on Kubernetes, and the part where variable is passed is surrounded by the green frame, such as the name of namespace or the names of Docker image used in deployment and tags, and also it used as hostname to root in English, which I will describe later. Another thing I'd like to talk about is routine. According to the mechanism of pull request-driven test, the pull request number are registered to DNS as subdomain dynamically. And the example is E2E Test.example.com domain. This is an assumption. And the wildcard of E2E Test example.com are all going through one load balancer to be accelerated. And the entire access to all E2E Test example.com is passed from load balancer to Nginx ingress controller. Nginx ingress controller is a controller of ingress handling routine, and Nginx is controlling the traffic outside Kubernetes cluster as reverse proxy. And PR-1 is a subdomain and the user accesses. And I am assuming the top layer and the Nginx controller. And in this case, the PR1 E2E-test.example.com. This is where we access, and there is a service. The ingress route to the service registered PR-2 subdomain is routed to the second pull request related service. The ingress host name, which was registered through customized mentioned area, is routed through a particular pull request. Let me show you an example of how it is actually used in GitHub. There are two timings of bot executing pull request driven tests. First is as shown on the left when commit is pushed to a particular label. In this case, the pull request with the label called deploy run E2E, surrounded by green circle. The commit is pushed and the deploy to Kubernetes server, and the automated deploy is done. The other trigger is, as the right-hand side shows, if the user implemented the command, and then the GitHub will deliver services according to the flow that I described earlier and comment. And the automated E2E testing starts seamlessly after commenting on GitHub the successful deploy. And after the test is over, the result of comment is returned and related test reports, links pasted, and on GitHub, the developer will be able to complete the execution of test as well as the confirmation of the result on GitHub. By introducing such a mechanism, the problem of E2E tests mentioned earlier have been solved to some extent. By running the E2E test in an independent environment, the data dependency that caused problems with concurrency and execution time has been eliminated to some extent. The problem of slow feedback to developers has also been dramatically speeded up by running E2E tests during the pull request stage before being merged into staging. As a result, there are some cases where bugs mixed in the staging environment can be prevented, and as a result, it has begun to contribute to improving the quality of applications. In addition, this was not intended, but the environment deployed for E2E testing was sometimes useful in code reviews as well. For instance, when you review a colleague's code, isn't it difficult to review it unless you move it at hand? In such a case, you usually pull the code pushed by your colleague and build it on your PC and run it on hand. The pull request-driven E2E test automatically deploys to the environment when a pull request is made. In other words, when you want to review your colleague's code, you don't have to bother to pull the code on hand and build it. In particular, if there are scenes where it was useful to use this environment as a preview when investigating when something went wrong. It may be hard to review if it can be only reproduced on hand. But this is called preview. By using this environment, the problem can be reproduced and can give the feedback immediately to your colleagues.
So, this is what we have done for Line Creators Market. And I would say we were very quick in doing so. Why? Because we have what is called line style, which include my favorite phrase, stay a step ahead. So, not getting everything ready as you run, just start running before they're ready. Don't wait until everything is ready. So, we are offering not what we want to build, but rather something that contributes to the service developers. So as soon as we have the minimum set of required functions, then they're used in the operational environment, and the developers will give us feedback and we work on it in our life cycle. So when we are done, it's not the end of it, because we have to continue improvement. Our objective is to enhance DX using this mechanism. So it may be a bit different from wanting to build something good. So the feedbacks from the service developers are extremely important. So we continue to improve ourselves. And toward the end of my talk, I also like to touch upon that. Now, currently, we are working on complete parallelism and reducing time of build to test. As I mentioned earlier, this pull request-driven E2E test is performed on pull requests just like unit tests and integration tests. In other words, if it takes too long for E2E tests to run, although it was supposed to improve DX, it could hamper the activities of service developers. Ideally, we want that test to be completed within the time in par with those with unit tests and integration tests. As I mentioned earlier, using this type of a mechanism, automated test can now be executed per pull request. However, for a single pull request, a single service is deployed. So, in multiple tests, if you have multiple changes to values in database or the states, we see conflicts between tests, resulting in the failure of the automated test. Just like the problems we saw in staging environment, the same thing can happen in pull request-driven tests. Therefore, some test cases were not completely parallelized. So the ideal situation would be the one-to-one relationship right on the right-hand side of this slide. One test case corresponding to one set of services. For example, A to PR1-1 and B equals PR1-2. In order for this to be realized, rather than executing tests after service is deployed, test instance can deploy necessary services. Test deploys services. By doing so, we no longer have to route. A complicated routing is not necessary to determine which test access which services. We always have one-to-one relationship between test cases and necessary service groups. So it seems much simpler. It looked very good. However, the service groups in parallelism can grow to great numbers. Therefore, maintaining parallelism with minimum resources still remains as a challenge for us going forward. Now, test instance itself deploys services. Therefore, the environment for preview can be deployed separately. By separating this preview environment from E2E tests, for example, preview environment, data can be changed without impacting the test cases. In the preview environment, your colleague may change the database, resulting in the failure of the test, and that can be now avoided. In this way, resource optimization and improvement in ease of use are the areas where we are continuously working on with the feedbacks from the projects. So, I'd like to summarize my talk today. There were two things I wanted to communicate to you. Number one is about this new role, and the other one was about engineering. Now, in terms of the roles, well, actually, the automated test engineers are the main part of our team, but now we have SETs, a new role. SETs and automated test engineers have different targets, although they are both test engineers. One aims at higher application quality, the other aims at higher DX, developer experience. Especially SETs. They don't just write test cases. They use test technologies to enhance DX for developers, contribute to the work environment of the developers. And the other part of my talk was about engineering, how we built this E2E test environment. The services are deployed in Kubernetes clusters per pull request, and E2E tests are executed seamlessly so that before merge into staging, E2E testing can be completed, accelerating the feedback loop for the service developers. As I mentioned earlier, it's not perfect yet. We are still working on improvement, but certainly we are very happy to continue working for further development, taking feedbacks from our developers. Thank you.